Basic setup for project efficiency, creating color variables. Setting up a consistent design system in your project is essential for ensuring visual harmony and efficient development. One of the foundational steps in achieving this is by creating and using color variables. Instead of hard-coding color values repeatedly, defining them as variables enhances both scalability and maintainability. This approach ensures that when you decide to update a color, you only need to make the change in one location, and it propagates throughout the project. Begin by determining the primary, secondary, and accent colors for your application's theme. Typically, this includes colors for backgrounds, text, buttons, and highlights. Create a dedicated file, such as colors.dart in Flutter or colors.js in JavaScript, to store these variables. Define them using descriptive names, for instance, primary color, secondary color, and error color. This not only makes your codebase more readable but also allows team members to quickly grasp the design intentions behind each color choice. Applying a font family for consistent typography. Typography is a vital aspect of user interface design, influencing readability and aesthetic appeal. Applying a consistent font family across your application ensures a cohesive user experience. Start by selecting a font that aligns with your application's branding and tone. Popular options like Roboto, Open Sans, or custom fonts often cater to various styles, from formal to playful. To implement a font family globally, integrate it into your project's theme settings. For example, in Flutter, use the theme data class to set the font family property, pointing to your desired font. Ensure that you've included the font files in your project and updated the pubspec.yaml file to load them. For web projects, link the font style sheet in your HTML file or import it via a package manager. Once applied globally, all text widgets or elements inherit the specified font, eliminating the need for repetitive declarations. This strategy not only reduces redundancy but also facilitates effortless updates if the font needs to be changed later. Creating a heading for player names. Clear and visually distinct headings for player names enhance user engagement and improve data organization. When designing a heading for player names, focus on size, weight, and spacing to differentiate it from regular text. In Flutter, consider using the text widget with style properties like font size, font weight, and color. For instance, a bold and slightly larger font size works well for headings, ensuring they catch the user's attention. Wrap the heading in a container or a padding widget to provide adequate spacing, preventing it from appearing cluttered. If your application features a list of players, consider using a list view widget with each item styled consistently. To further enhance the design, incorporate icons or badges alongside player names, denoting their rank or status. These subtle additions not only add a layer of interactivity but also improve the overall user experience. Optimizing color variables for dark and light modes. Incorporating dark and light modes into your application has become a standard practice, offering users flexibility and comfort. When setting up color variables, plan for both themes from the beginning. Use a color palette generator or design tool to select complementary shades for each mode. Store these in separate maps or classes, such as light colors and dark colors. In Flutter, you can leverage the theme data class to switch themes dynamically based on user preferences or system settings. For instance, define a theme mode variable and toggle between theme mode.light and theme mode.dark. Ensure your color variables are used consistently across all widgets to avoid mismatched styles. Testing both modes thoroughly is crucial, as subtle differences in contrast can significantly impact readability and usability. By thoughtfully planning your color variables, you ensure a seamless and visually appealing experience for users, regardless of their preferred theme. Customizing fonts for different sections. While a global font family creates uniformity, customizing fonts for specific sections adds a layer of distinction and hierarchy to your design. For instance, you might choose a bold, decorative font for headings, a clean sans serif for body text, and a mono-spaced font for code snippets or statistics. In Flutter, this can be achieved by defining multiple text style objects in your theme or as constants in a separate file. Use these styles selectively by applying them to the style property of text widgets. This approach not only simplifies style management but also ensures consistency across similar components. Experiment with font weights, sizes, and letter spacing to create a balanced visual hierarchy. When implementing custom fonts, remember to test their readability across various screen sizes and resolutions to maintain accessibility. Designing an accessible and responsive typography system. Accessibility and responsiveness are key considerations when designing a typography system. Ensure your text is legible for users with varying levels of vision by adhering to recommended contrast ratios and font sizes. For headings, choose a minimum size of 24px or its equivalent, scaling down proportionally for subheadings and body text. Use tools like dynamic font scaling in Flutter, MediaQuery.text scale factor, to adapt text sizes based on user preferences. Additionally, implement responsive design principles to adjust font sizes for different screen dimensions. In a multi-language application, consider the nuances of different scripts, as some may require additional spacing or alternative font families for optimal readability. By prioritizing accessibility and responsiveness, you create a user-friendly interface that accommodates a diverse audience. Using semantic names for colors and fonts. Semantic naming of colors and fonts improves code clarity and maintainability. Instead of using vague names like Blue1 or Font1, opt for descriptive terms such as primary background, highlight text, or error font. This practice ensures that developers can quickly understand the purpose and context of each variable, reducing the learning curve for new team members. In addition, semantic names align with the principles of self-documenting code, minimizing the need for extensive comments. When naming colors and fonts, consider their roles in your application's design system and future scalability. For instance, a variable named success color can adapt to different shades of green depending on the theme, without requiring a name change. This foresight streamlines updates and enhances collaboration within the development team. Enhancing UI with dynamic color transitions. Dynamic color transitions add a polished and interactive feel to your application. These transitions can be used for hover effects, theme changes, or animations, creating a seamless visual flow. In Flutter, leverage the animated container widget to implement smooth color changes based on state variables. For example, when toggling between light and dark modes, animate the background color transition to enhance user perception. Similarly, apply gradients or animated overlays to emphasize actions like button presses or item selections. Ensure these transitions are subtle and quick, typically under 300 milliseconds, to maintain a responsive interface. Testing transitions on various devices is crucial, as performance can vary based on hardware capabilities. Structuring code for scalability and reusability. Well-structured code is the backbone of scalable and maintainable projects. Centralizing design elements, such as colors and fonts, into dedicated files promotes reusability and reduces duplication. For instance, create a theme.dart file to encapsulate your application's color schemes, typography, and spacing guidelines. Group Group related variables and components into logical modules, ensuring that each file serves a specific purpose. This modular approach not only simplifies navigation but also facilitates parallel development, enabling team members to work independently on different sections. Regularly refactor and review your code base to identify and eliminate redundancy. By adhering to these practices, you build a robust foundation for your project, accommodating future growth and complexity. Iterating on player name headings for user engagement. The design of player name headings plays a significant role in capturing user attention and conveying information effectively. Experiment with different font styles, colors, and decorations to find a combination that resonates with your audience. Incorporate dynamic elements like hover effects or animations to add interactivity. For example, when a user hovers over a player's name, display additional details or stats in a tooltip or pop-up. This approach not only enriches the user experience but also encourages exploration and engagement. Collecting user feedback is essential for refining these designs, as real-world usage often reveals insights that static testing cannot. Continuously iterating on player name headings ensures they remain relevant and effective, aligning with evolving user expectations and design trends. Creating a box layout for Tic Tac Toe. When designing a Tic Tac Toe game, one of the essential elements is setting up a clear and organized box layout that will display the game grid. The grid is crucial because it defines the spaces where players will place their marks, either X or O. The layout needs to be intuitive, responsive, and flexible, allowing the game to scale across various screen sizes. To achieve this, we can utilize a combination of Flutter widgets such as GridView.Builder, Container, Spacer, and Expanded to create a responsive and functional grid. The GridView.Builder widget is particularly useful for constructing a grid dynamically. This widget helps to create a grid with an efficient memory model, which is ideal when you're dealing with a grid layout that can potentially have many items or dynamic elements. For our Tic Tac Toe game, we can use GridView.Builder to build the grid of 9 cells, each corresponding to one square in the game. The beauty of this widget lies in its ability to lazily generate only the items that are currently visible on the screen, which makes it performance efficient for larger grids. Each cell in the Tic Tac Toe board will be a small box or container, and container widgets play an important role in providing styling, padding, and background colors to these cells. A container can easily be customized to fit the design needs of the Tic Tac Toe board, from defining its size to adding borders or even setting different background colors to distinguish between empty, X, or O cells. The container widget is one of the most versatile and widely used widgets in Flutter because of its ability to combine various properties like decoration, alignment, and padding in one easy-to-use widget. Another crucial widget for creating this layout is Spacer. This widget helps to create flexible spacing within the layout. A spacer can be particularly useful in the grid for managing the spacing between rows or columns, ensuring that the grid cells maintain an equal distance from each other regardless of screen size or orientation. The spacer widget automatically takes up as much space as possible, and by placing it in certain places within the layout, we can make sure that the Tic Tac Toe grid remains balanced and symmetrical. Using Expanded in conjunction with Spacer or Container can help control how the available space is distributed within the grid layout. By wrapping a widget in an expanded widget, it will occupy all the available space along the main axis, either horizontally or vertically. In the context of the Tic Tac Toe game, Expanded allows the grid cells to stretch and fill up the screen, making sure that each box within the grid maintains a consistent size. When combined with GridView.Builder, Expanded ensures that the game grid looks great on different screen sizes, from small phones to large tablets. To conclude, creating a box layout for a Tic Tac Toe game requires careful consideration of how elements are structured and spaced on the screen. By leveraging the power of GridView.Builder, Container, Spacer, and Expanded, you can design a layout that is not only functional but also flexible and adaptable to different screen sizes. These widgets give you control over how the game grid is displayed and ensure that the game experience is consistent and enjoyable for all players. Creating game buttons with styles. The next important step in building our tic-tac-toe game is designing the game buttons. These buttons allow players to interact with the game by selecting a grid cell to place their mark, either X or O. The design and styling of these buttons play a significant role in creating a user-friendly and visually appealing experience. To achieve this, we need to understand how to use Flutter widgets such as container, expanded, spacer, and other styling techniques to design buttons that are both functional and stylish. A button in the context of a tic-tac-toe game is more than just a simple tap target. It needs to have a clear visual state that shows whether it's empty, occupied by an X, or occupied by an O. This is where the container widget comes into play. The container allows us to define a button's size, shape, color, and padding. Using the decoration property of a container, we can easily add borders, rounded corners, background colors, and even shadows to make the button visually appealing. For instance, an empty cell could be a simple square with a border, while a cell with an X or O could have a different color or border style to indicate its state. Another crucial aspect of button design is the ability to handle user interaction. When a player taps on a grid cell, it should trigger an action in the game, such as placing an X or O. For this, Flutter's gesture detection system comes into play. The gesture detector widget can wrap each button, which is essentially a container, and it allows you to handle taps, drags, and other touch events. By adding a gesture detector to our button container, we can listen for tap events and respond accordingly, such as updating the game state and re-rendering the UI to show the player's mark. A stylish button also needs to provide feedback when the user interacts with it. Flutter's Inkwell widget is a perfect tool for this purpose. It adds a splash effect to the button when it's tapped, giving the player immediate visual feedback that their action has been registered. The splash effect is subtle but enhances the tactile feel of the game. By customizing the Inkwell widget, we can control the ripple effect, making it more visually satisfying and ensuring that the game feels responsive to the player's touch. Expanded is another widget that can help us with layout control. When designing the tic-tac-toe buttons, it's important to ensure that they fit perfectly within the grid and maintain a uniform size across different devices. Using the expanded widget ensures that each button takes up an equal amount of space within the grid, ensuring a consistent layout. This is especially useful when the screen size changes, as the buttons will automatically resize to fit the available space. By wrapping the button container in an expanded widget, we ensure that it maintains a flexible and adaptable design across devices. Spacing between buttons can also be controlled using the spacer widget. Although the grid view builder will automatically handle most of the layout for the grid, using spacer can help add additional gaps between rows or columns of buttons. This helps to prevent the buttons from feeling cramped or crowded, especially when dealing with smaller screen sizes. A well-spaced layout ensures that the buttons are easy to tap and the game feels pleasant to play. Styling the buttons is more than just adjusting their size and color, it's also about creating a consistent and attractive theme. You can apply gradients, borders, and shadow effects to create buttons that visually stand out and fit with the overall aesthetic of your tic-tac-toe game. Customizing button styles in this way gives your game a unique look and feel, setting it apart from other tic-tac-toe implementations. In conclusion, creating game buttons with styles requires a combination of functionality and aesthetics. By using widgets like container, expanded, spacer, and gesture detector, you can create buttons that are not only visually pleasing but also highly interactive and responsive. The ability to style these buttons with borders, colors, and effects enhances the user experience and adds a layer of polish to your tic-tac-toe game. With careful attention to button design and interaction, you can ensure that your game is both enjoyable and easy to play. Understanding the Grid View Builder widget. When designing a tic-tac-toe game, one of the most fundamental components is the layout of the game grid. A dynamic and efficient way to achieve this grid is through Flutter's GridView.Builder widget. The GridView.Builder is specifically designed to handle grid-based layouts, making it ideal for creating the tic-tac-toe board where each cell corresponds to a button or interactive space in the game. Understanding how to leverage this widget can greatly improve the performance and flexibility of your grid-based design. The GridView.Builder is a widget that lazily constructs a grid of items. Unlike a simple grid view widget that requires you to specify all the items in advance, the GridView.Builder builds each grid item only when it is needed, which is especially useful for large grids or when the number of grid items can vary. For a tic-tac-toe game, where the grid is always 3x3, the builder model might seem like overkill, but it's a great choice for scalability if we decide to expand the game or need to handle dynamic content in the future. This widget works by using a builder function that creates individual cells in the grid. Each item in the grid is defined by the item builder function, which is responsible for creating the contents of the grid cell. This allows you to easily modify how each cell looks and behaves. In the case of tic-tac-toe, each grid cell can be represented by a container widget, which is styled to show whether the cell is empty, filled with an X, or filled with an O. The GridView.Builder will take care of rendering and positioning each container in the correct location, ensuring a smooth and responsive layout. One of the primary advantages of using GridView.Builder in our tic-tac-toe design is its efficiency. Since the widget only builds grid cells that are visible on the screen, it minimizes memory usage, which is particularly helpful in scenarios where you have more complex grids or a larger number of items. Additionally, GridView.Builder can be customized to create grids that scroll in both vertical and horizontal directions, which adds flexibility to your design. The GridView.Builder widget is also highly customizable in terms of the layout. You can define the number of columns and the size of each cell using properties like cross-axis count and child aspect ratio. These properties allow you to tailor the appearance of the grid to your specific design needs. For tic-tac-toe, you could set the number of columns to 3, as it's a 3x3 grid, and adjust the aspect ratio of each cell to ensure that they are square-shaped, providing a visually balanced and organized board. Another important feature of GridView.Builder is its ability to handle item separation through properties like main axis spacing and cross-axis spacing. These properties allow you to control the spacing between the grid cells, making it easy to create a well-spaced, clean design that avoids any clutter. This becomes particularly useful when working with touch-based interfaces, as the spacing between the buttons ensures that each grid cell is easily tappable. Finally, the GridView.Builder widget is a highly flexible tool for creating dynamic and efficient layouts. While it's particularly useful for grids with a large number of items, it's just as effective for smaller, static grids like tic-tac-toe. It gives developers the ability to build clean, responsive, and performant user interfaces without needing to worry about manually creating each item in the grid. By utilizing GridView.Builder, you ensure that your tic-tac-toe game is both efficient and adaptable. In any game, buttons are one of the most common UI elements used to facilitate player interaction. These buttons serve a variety of purposes, from starting a new game to accessing settings or navigating menus. Creating buttons in a game development environment involves both functional and visual considerations. Functionally, a button must respond to user input, typically mouse clicks or touch inputs, by triggering specific actions, such as loading a new screen, pausing the game, or changing game settings. Visually, buttons need to be designed in a way that is both intuitive and appealing, guiding players to their desired actions without causing confusion. In the process of creating buttons, the first step is to choose the right development environment. Game engines like Unity and Unreal Engine, along with libraries such as Godot or Cocos 2D, offer specific tools and frameworks for UI creation. For example, Unity uses its UI system, which includes the button component, allowing developers to easily create and manage buttons within a scene. The design process begins with defining the size and position of the button on the screen, followed by defining its appearance and interaction states. A typical button design requires multiple visual states: idle, hovered, clicked, and disabled, each with distinct visual cues to inform the player of the button's status. These states are often represented with changes in color, size, and slash or animations. For example, a button may change from gray to blue when hovered over, and from blue to green when clicked, indicating different levels of user interaction. Animations or transitions can also be added to create smoother, more engaging feedback when the button is interacted with. These animations can be triggered when the mouse cursor enters or exits the button area, or when the user clicks the button. Buttons can also include text or icons to make it clear what action they perform, such as start game, options, or exit. Event handling is another crucial part of creating buttons in game development. When a button is clicked or tapped, it needs to trigger specific functions within the game, such as navigating to a new screen, updating a variable, or executing a script. This is typically accomplished by attaching event listeners to the button in code. In Unity, for example, this would involve attaching a function to the on-click event of the button component. This function could be a method that transitions to a new scene or pauses the game, depending on the button's intended purpose. The importance of user experience, UX, and accessibility cannot be overstated when creating buttons in games. Buttons must be easy to see and interact with, especially for players with different needs and preferences. Designers should ensure that the buttons are large enough to interact with on various screen sizes and devices. Additionally, providing visual feedback such as highlighting or scaling the button on hover improves accessibility and usability. Furthermore, buttons should be easily reachable in terms of placement, ensuring that players don't have to stretch their fingers too much or perform overly complicated movements. To cater to all players, it's also important to implement keyboard and controller support for button navigation. In conclusion, the creation of buttons in game development involves a balance between design and functionality. Developers need to ensure that the buttons are visually appealing, intuitive to use, and properly integrated into the overall game experience. Effective button design enhances gameplay and improves the player's interaction with the game, ultimately contributing to a more polished and enjoyable game. The design and implementation of buttons must always prioritize usability and accessibility to ensure that all players, regardless of their input method, can engage with the game seamlessly. Advanced techniques for creating buttons in game UI. While creating simple buttons in games may seem straightforward, there are several advanced techniques and best practices that can elevate the overall UI design. One of the most important aspects of advanced button creation is animation. Buttons in modern games are often equipped with complex animations that respond to various user actions, adding an extra layer of polish and engagement. These animations can range from subtle effects like scaling or color shifts to more elaborate actions such as bouncing or rotating when the button is clicked or hovered over. In Unity, for instance, button animations can be created using the built-in animator component or by leveraging Unity's UI system along with scripts that change the button's properties over time. The animation could include scaling the button up when the user hovers over it, giving the effect that it is slightly rising off the screen. This provides visual feedback to the player, making the interaction feel more tangible and satisfying. Additionally, the use of easing functions can make animations feel smoother and more natural, avoiding abrupt movements that may break the immersion. Another advanced technique is integrating buttons with dynamic UI systems. This approach allows buttons to adapt based on the game's current state. For example, during a battle sequence in an RPG, the buttons in the menu may change depending on what actions are available to the player. A button may appear as attack or defend during combat, and it could transform into cast spell if the player's character has acquired magical abilities. This requires dynamically altering the button text and functionality based on the game's logic, adding a layer of interactivity and immersion. Responsive design is also a critical aspect of creating advanced buttons in games. This is especially important when games are being designed for multiple platforms, such as PC, console, and mobile. A button that looks great on a large desktop screen might not translate well to a smaller mobile screen. Similarly, a button that works perfectly with a mouse and keyboard might be difficult to interact with on a touch screen or with a gamepad. Developers need to take these differences into account, creating flexible UI elements that can scale, reposition, and resize depending on the device the game is running on. Moreover, developers often use sound effects in combination with button animations to enhance the player's experience. For example, a subtle sound effect can play when the player hovers over a button, signaling that it is interactive. This audio cue can provide additional feedback, improving the overall accessibility for players who might not notice visual changes alone. One challenge that comes with creating advanced buttons is optimizing performance, particularly in resource-intensive games. Buttons and their animations can add to the graphical load, potentially leading to frame rate drops or other performance issues. Developers must ensure that the button designs are not too resource-heavy and that they work smoothly across all targeted devices and platforms. This may involve optimizing the number of animations, textures, and other graphical assets used for buttons, ensuring that the UI remains fast and responsive even in demanding situations. Finally, it is essential to consider the player's experience with button interaction. Advanced button systems may include state-dependent features, such as the ability to disable buttons when certain conditions are not met. For example, if the player's character is out of health, a use potion button might become disabled, preventing the player from interacting with it. Similarly, buttons may be grouped or layered to create a more intuitive experience, allowing players to focus on the most important actions without distraction. In conclusion, creating advanced buttons requires an understanding of both technical implementation and user experience. By utilizing animations, dynamic UI systems, responsive designs, sound effects, and performance optimization techniques, developers can create a more immersive and interactive experience for players. As with all aspects of game design, the goal is to create a seamless, intuitive, and enjoyable user interface that enhances the overall gameplay experience. Changing the UI of a game screen, understanding the basics. The user interface, UI, is a vital part of any game, serving as the bridge between the player and the game world. Changing the UI of a game screen involves more than simply adjusting button placement or colors. It requires a deep understanding of how UI elements interact with the player's experience and how they can be adapted to enhance gameplay. The game screen's UI needs to evolve in a way that fits the flow of the game, guiding the player through different stages, levels, or modes while ensuring the interface remains clear, responsive, and aesthetically pleasing. The first step in changing the UI of a game screen is understanding the purpose of each UI element. The UI might include buttons, sliders, health bars, maps, inventory screens, dialog boxes, and more. Each of these elements serves a specific function in helping the player interact with the game world. Health bars, for example, are critical in action games, showing the player's current status and indicating when they need to be more cautious. Inventory screens are important in RPGs, allowing players to manage their items and abilities. Once the purpose of each UI element is clear, designers can move on to layout and design considerations. Layout refers to the arrangement of all the different elements on the screen. A well-designed UI layout should be intuitive, keeping the most important elements easily accessible and in the player's line of sight. The placement of health bars, buttons, and mini-maps should take into account the player's interaction habits and the game's pacing. For example, in a fast-paced action game, elements like health bars and ammo counts are typically placed at the top or bottom of the screen so that the player can glance at them quickly without losing focus on the action. Conversely, in a puzzle game, the UI might be more minimalistic, with elements placed in a way that allows players to focus on the puzzle without distraction. Changing the UI often involves adjusting or adding new components as the player progresses through different levels or stages. For example, in some games, new features or abilities may be unlocked, necessitating the addition of new UI elements to accommodate them. This can involve adding buttons to navigate a new menu, or displaying new icons to represent abilities that have become available. Similarly, the UI may need to change depending on the game's Introduction to handling game turns in Flutter. In any game, especially two-player games like Tic Tac Toe, the concept of turns is crucial to the flow of the game. A turn is the interval of time during which a player can make a move. For Tic Tac Toe, these moves typically involve placing either an X or an O within a 3x3 grid. The core gameplay revolves around the alternation of turns between two players, ensuring fairness and keeping the game dynamic and engaging. In modern mobile development, Flutter offers a vast array of tools and widgets that allow us to build interactive UIs with minimal complexity. One of the most common user interface patterns for such games is grid-based layouts, which provide an intuitive way to present the game's board to players. But building a functional, interactive game requires more than just displaying a grid. It's about managing game states, handling user input, and dynamically updating the interface. Flutter provides an elegant solution to this challenge with its reactive framework, which helps developers create real-time game experiences by using a combination of widgets like Container, GridView.Builder, and Sized Box. When building a game like Tic Tac Toe, the first challenge is managing the turns. The game must know whose turn it is, whether it's player X or player O. Typically, when one player takes their turn, the game needs to update the grid to reflect their move, and then it must switch to the other player's turn. Flutter makes managing the state straightforward with its stateful widget system. Every time a player interacts with the grid, the game needs to update its internal state, indicating which player made the move and which square they chose. This update is typically done using a data structure, such as a list or array, to track which squares are filled and by which player. Every click on a grid square triggers a state change, and Flutter's framework ensures that the UI updates accordingly. The GridView.Builder is an efficient widget for rendering a grid of cells, and when combined with Container for individual cell rendering, it allows for both clean layout and responsive gameplay. The Sized Box widget, though not central to game logic, plays an important role in controlling the visual spacing between game elements, ensuring that the layout remains clean and visually appealing. This combination of widgets allows Flutter developers to implement the core mechanics of a turn-based game with ease. Through this simple yet powerful set of tools, you can efficiently handle the complex process of managing game turns, creating an enjoyable and responsive experience for users. Switching turns in the game logic. One of the core mechanics of any turn-based game is switching between players after each turn. In Tic Tac Toe, players alternate placing their symbols, typically X and O, on the game grid. Handling this alternation in Flutter involves changing the game state each time a player makes a move. This can be achieved by using a Boolean variable or integer that toggles between the two players. For example, you might define a variable like isXTurn, which would be set to true when it's player X's turn and false when it's player O's turn. When a player taps on an empty cell, the game checks whether isXTurn is true or false. If it is true, the game places X in the tapped cell, and then the value of isXTurn is switched to false, signaling that it is now player O's turn. Conversely, if isXTurn is false, the game places O in the tapped cell and switches the turn back to player X. This alternation of turns continues until one player wins or the grid is filled. The turn switching logic is fundamental to keeping the game fair and ensuring that each player has an equal opportunity to participate. Managing game turns also involves keeping track of the current state of the grid, ensuring that players cannot make invalid moves. This means checking whether a cell is already filled before allowing a move. If a player taps on a cell that has already been filled, the game should ignore that tap and wait for a valid move. Furthermore, once a player has made their move, the game's UI should update to reflect the new state, displaying either X or O in the appropriate cell. Switching turns in this way ensures that the game proceeds smoothly, and that players are always aware of whose turn it is. State management and its importance in game turns. State management is one of the most fundamental concepts in Flutter, and it plays a pivotal role in building interactive applications like games. Games, by their nature, have a dynamic state that changes based on user interaction, such as when a player makes a move or the game reaches an end condition. For Tic Tac Toe, this means tracking the game grid and the alternating turns of the players. Without proper state management, it would be impossible to correctly update the grid, switch turns, or check for victory conditions. Flutter offers several ways to manage state, but for this purpose, the most common approach is using stateful widget along with setState. Understanding how state management works is essential for creating a smooth and reactive user experience, and it allows us to break down the problem into manageable pieces. When creating a tic-tac-toe game, the game state is usually stored in an array, or a similar data structure, that represents the 3x3 grid. Each element in this array can either be empty, marked by an X, or marked by an O. The challenge lies in updating this array when a player makes a move. When the user taps on a cell, the corresponding element in the array is updated, and then the turn alternates between the two players. To ensure the UI reflects these changes, Flutter provides the setState method, which is used to notify the framework that the internal state of the widget has changed. Once setState is called, Flutter rebuilds the widget tree and updates the UI to reflect the new state. This is crucial in a turn-based game, where the interface needs to update quickly after every user interaction. Managing the state also involves tracking whose turn it is. Typically, you would use a simple Boolean flag or an integer that toggles between two states. For instance, if his X turn is true, it's player X's turn; if his X turn is false, it's player O's turn. This flag would be checked whenever a user taps a square on the grid. If the square is empty, the game updates it with the current player's symbol and then switches the turn. A key challenge in state management is ensuring that the game correctly responds to user input and doesn't allow a player to make a move on an already filled cell. To handle this, the game needs logic to check if the selected cell is empty before updating the state and refreshing the UI. Flutter's declarative nature makes it particularly well suited for such dynamic state management. Using a combination of stateful widget, setState, and proper checks on the grid state, you can ensure that game turns are handled smoothly. Handling user input with gesture detector. Handling user input is a key part of building interactive games, and Flutter makes it easy to manage taps and other gestures with the gesture detector widget. The gesture detector listens for different kinds of user interactions, including taps, swipes, and long presses. For a game like Tic Tac Toe, the most important gesture is the tap, as players will be tapping on the grid cells to place their symbols. To make each grid cell interactive, we wrap each container, representing a grid cell, in a gesture detector. The onTap property of the gesture detector listens for tap events, and when a tap occurs, it triggers a callback function that handles the logic of the game. When a player taps a cell, the callback function checks if the cell is empty. If the cell is empty, the game updates the state by marking the cell with the current player's symbol, either X or O. After updating the cell, the game must switch to the next player's turn, so the function toggles the state of the turn indicator, for example, from his X turn to his O turn. This ensures that the game alternates turns between the two players. The gesture detector is a powerful tool because it provides a simple and declarative way to handle user input without requiring complex event management systems. It allows the UI to respond directly to user interactions, making the game feel more responsive. In addition to managing the game turns, the gesture detector can also be used to detect other gestures, such as long presses, to add additional functionality like a restart button or other game features. The flexibility of gesture detector makes it easy to extend the game's functionality without adding unnecessary complexity. However, while gesture detector handles the gestures, the game logic itself must be carefully implemented to ensure that players can't make invalid moves, like clicking on a cell that has already been filled. The game state should be checked on each tap, and if the cell is not empty, no update should occur. This ensures that players can only interact with valid grid cells, and the game remains fair and enjoyable. Leveraging container for individual grid cells. In Flutter, the container widget is highly versatile and is often used to style and position individual elements within a layout. When building the grid for Tic Tac Toe, each cell in the grid needs to be visually distinct and clickable. The container widget provides an excellent way to encapsulate each grid cell and give it a customized appearance. Containers allow you to define the size, padding, decoration, and alignment of each cell, which makes it a perfect choice for building the UI of a game board. Each container in the grid can be styled to represent either an empty space or the X or O placed by the players. For example, you can use the decoration property to add a border around each cell and give the background a different color depending on whether the cell is filled or not. For instance, a cell could have a white background if it's empty, a blue background if it's filled with X, and a red background if it's filled with O. This immediate visual feedback makes the game engaging and easy to follow for the player. Additionally, Container allows for easy customization of cell sizes. The size of each grid cell can be adjusted to fit the overall layout of the game board, ensuring that the game looks great on various screen sizes. This can be done using the width and height properties or, for more flexibility, by using a sized box within the container to further control the cell's dimensions. Introduction to the Flutter Tic Tac Toe game. Creating a Tic Tac Toe game is a popular project for Flutter developers, as it allows you to combine both UI design and game logic. Flutter, as a powerful UI framework, enables developers to easily craft interactive mobile applications, and building a game like Tic Tac Toe offers a great opportunity to learn essential Flutter concepts while creating an engaging, interactive app. Tic Tac Toe is a simple two-player game that takes place on a 3x3 grid. The goal is for players to take turns marking an empty spot on the grid with either an X or O, aiming to get 3 of their marks in a row, column, or diagonal. The game ends when either one player achieves this or when all spots on the grid are filled without a winner, a tie. From a development perspective, creating a tic-tac-toe game requires understanding several key components such as handling user inputs, tracking game states, detecting win conditions, and updating the user interface, UI, accordingly. This video tutorial will focus on 3 key aspects of building a tic-tac-toe game using Flutter: pattern matching, implementing winner detection, and modifying the UI of the game screen. Pattern matching. Pattern matching in the context of tic-tac-toe refers to identifying specific patterns within the game grid. The game requires that you check whether a player has placed their marker, X or O, in a way that forms a winning combination, 3 consecutive marks in a row, column, or diagonal. Understanding how to perform pattern matching is essential for determining when a player has won or when the game has ended in a draw. In this tutorial, we'll dive deep into how to implement pattern matching logic that can identify a winning combination. We'll cover how to track the state of the game board and how to check for these winning combinations across multiple directions. This is fundamental for the game's logic to function properly and allows us to detect a winner in real time as players take their turns. Winner detection. After implementing the grid and tracking player moves, the next important aspect is detecting when one player has won the game. Winner detection involves checking the state of the board to identify whether 3 marks, either X or O, align in a row, column, or diagonal. Additionally, we need to handle edge cases, such as when all cells are filled without any player winning, resulting in a draw. This section will focus on the core logic for determining the winner, providing a comprehensive understanding of how to continuously evaluate the board after each move. This process is necessary for ensuring the game's flow is accurate and that the user experience remains smooth and logical. Changing the UI of the game screen. While the game logic forms the backbone of any game, a visually appealing user interface enhances the overall player experience. Flutter makes it easy to customize the UI, and in this tutorial, we'll explore how to design an interactive 3x3 grid that responds to player taps, as well as how to dynamically update the UI based on the state of the game. In addition to the layout of the grid itself, we will also look into customizing the design to make the game feel engaging, from displaying player markers, like X and O, to providing feedback such as victory messages, animations, and a button to restart the game. These UI enhancements will not only make the game visually attractive but also improve its functionality by providing clear instructions and status updates to the players. By the end of this tutorial, you'll have gained a solid understanding of how to create a tic-tac-toe game in Flutter, including how to manage game logic, detect winners, and design an interactive and user-friendly interface. Understanding pattern matching in Flutter. Pattern matching in tic-tac-toe is the critical process that checks if a player has achieved the objective of aligning three of their symbols, X or O, consecutively in any direction, horizontally, vertically, or diagonally. This step is fundamental to determining when the game should end and declaring a winner. Flutter, as a UI toolkit, provides the flexibility to implement this logic by utilizing its built-in features for layout and state management. In the context of a tic-tac-toe game, the grid is usually represented as a 3x3 matrix. Each cell of this matrix can either be empty, marked with an X or marked with an O. The goal is to continuously check whether any row, column, or diagonal contains three of the same symbol. This pattern matching process is what makes the game interactive and dynamic. The first step in implementing pattern matching is to define the state of the game board. This board is typically represented as a collection of cells, with each cell containing the value of the player who occupies it. For example, a 3x3 grid might be represented as a 2D array or a list of lists in Flutter. The state of each cell can be represented by an empty string when unmarked, X when the first player makes a move, and O when the second player makes a move. Once the board is initialized, the game logic must include functions to check each row, column, and diagonal to determine if any of them contain three consecutive marks from the same player. A row consists of the three cells that are horizontally aligned, a column consists of the three vertically aligned cells, and a diagonal consists of the three cells that are aligned diagonally from the top left to bottom right or top right to bottom left. Checking for these patterns allows the game to identify if any of these conditions have been met, signaling that a player has won the game. Pattern matching also plays a role in preventing invalid moves. If a player attempts to mark a cell that has already been occupied, the app should disregard the action and prompt the player to choose another cell. This ensures that the game rules are followed strictly. It's important to note that pattern matching involves not only checking for winning combinations but also determining if the game has reached a state where no more moves can be made, resulting in a draw. This check occurs when all the cells are filled and no winning combination has been achieved. By implementing pattern matching correctly, you create the foundation for the game's logic. This ensures that each move made by the player is evaluated, and the game's flow is managed appropriately, allowing for a smooth and consistent gaming experience. How to implement winner detection. Winner detection is the process of determining if a player has won the game by placing three of their marks consecutively on the grid. After setting up the pattern matching logic, winner detection plays a crucial role in the game's flow. Once a player places their mark, the game needs to evaluate whether their action resulted in a winning combination. In tic-tac-toe, a player wins if they manage to place three of their marks in a row, column, or diagonal. This can occur in multiple ways, and each scenario must be checked after every move. The player who successfully aligns three marks in any of these directions is declared the winner, and the game should stop further input and display the winning player's marker. However, if all cells on the board are filled and no player has achieved this goal, the game ends in a tie. The core concept behind winner detection is evaluating the game board after each move to see if any of the winning conditions have been met. This involves checking each of the rows, columns, and diagonals to see if they contain three matching symbols, either all XS or all OS. It's important to check the board after each move to ensure that the game reacts in real time, preventing any further moves once a winner is detected. Detecting the winner requires traversing the grid systematically. For each row, column, and diagonal, you compare the values of the cells. If all three cells contain the same symbol, either X or O, then that player has won. This is the simplest form of winner detection. However, in cases where the board is full but no player has won, the game should be able to detect a tie and notify the players that the match has ended without a winner. In addition to detecting the winner, the game must also manage the flow once a winner is detected. This means that once a winner is found, the game should lock the grid and prevent further moves from being made. A message should be displayed to announce the winner and prompt players to start a new game. In the event of a tie, the game should similarly inform the players and allow them to restart the match. Winner detection is an ongoing process that occurs after every turn. It's vital to ensure that the game checks the win conditions consistently and efficiently, without any delays, to provide a seamless experience for the player. By implementing solid winner detection logic, the game becomes engaging, ensuring players understand when they have won, when the game is a tie, and when it's time to restart. Changing the UI of the game screen. Creating a visually appealing user interface, UI, is a critical component of building a successful game. In the case of Tic Tac Toe, the user interface should not only be intuitive and easy to use but also interactive and responsive to player actions. The Flutter framework makes this process relatively straightforward by providing powerful UI components and layout mechanisms. The core UI element of a tic-tac-toe game is the 3x3 grid. This grid serves as the playing field where players will place their X or O markers. In Flutter, this grid can be created using various layout widgets, with grid view and row and column being some of the most common choices. These widgets allow you to structure the cells of the game board while ensuring the layout is flexible and responsive across different device sizes. The grid must be interactive, meaning that each cell must be clickable so players can place their markers. This requires using widgets that capture user input, such as the gesture detector widget, which listens for touch events on each grid cell. When a player taps a cell, the corresponding action should be triggered to update the board and alternate between players. In addition to the basic grid layout, the UI should also visually reflect the game state. This includes showing the current player's marker, X or O, in the tapped cells and updating the game screen dynamically as the game progresses. For instance, once a player places their marker, the cell should update immediately, providing real-time feedback. The UI should also visually display which player's turn it is, typically through a small indicator or text at the top of the screen. Understanding the winner logic in tic-tac-toe, get winner. Tic-tac-toe is one of the simplest yet most captivating games, known for its straightforward rules but deep strategy. The primary goal of the game is for a player to align 3 of their marks, either X or O, in a straight line horizontally, vertically, or diagonally. This makes the logic of determining the winner the central pillar of the gameplay experience. Implementing a get-winner function in a tic-tac-toe game in Flutter requires a firm understanding of both the game rules and how to handle game state updates in a user interface that reacts dynamically to the player's moves. In a traditional 3x3 grid, the winning conditions are straightforward. There are 8 possible winning lines. These consist of 3 horizontal rows, 3 vertical columns, and 2 diagonals. For each of these lines, the game must check if all 3 positions are filled with the same player's mark, either X or O. If any of the lines meet this condition, the game should immediately declare that player the winner. Once a player wins, no further moves should be allowed, ensuring that the game has a clear and unambiguous result. The real challenge of determining the winner lies in efficiently checking these winning conditions after every move. For every move, the game must evaluate all 8 potential winning lines, comparing the 3 marks in each to see if they are identical. For example, if the first row contains the marks at positions 0, 0, 0, 1, and 0, 2, the game must check if they are all the same. If they are, the player who placed those marks is the winner, and the game halts. The same check is performed for all rows, columns, and diagonals, ensuring that no possible winner is overlooked. To implement this logic effectively, the board is often represented as a 2D array or list in Flutter. This array will contain 9 elements, representing each of the cells in the tic-tac-toe grid. These elements are typically initialized to null or an empty value to represent empty spaces. As the game progresses, the elements in this array will be filled with either X or O. After every move, the game will check the current state of the array to see if any of the rows, columns, or diagonals meet the winning conditions. While the basic logic for determining the winner is simple, comparing the 3 marks in a line, several edge cases must be handled. For instance, the game must ensure that the player has actually filled all 3 positions of a line before declaring them the winner. If a player attempts to make a move in an already filled spot, or if there's an incomplete line, the game should prevent this and request a valid move. Similarly, the winner checking function must also ensure that after a winner is found, the game stops further evaluation. This prevents any unnecessary checks after the game has concluded. An important consideration in the winner logic is managing the state of the game board. The game needs to evaluate whether a player has won after each turn, but it also needs to check for draw situations where the grid is completely filled without any player aligning 3 marks. Once the game recognizes a winner or a draw, it should immediately end, and the UI should reflect the results, notifying the player of the outcome. Handling game over scenarios seamlessly is essential for a positive user experience. Additionally, it is helpful to design the game so that if the players wish, they can quickly restart the game for a new round. A final aspect of winner detection in tic-tac-toe is the visual and user experience design. After detecting a winner, it is essential to provide immediate feedback to the players. This feedback could be as simple as a message displaying player X wins, or player O wins, but the game could also visually highlight the winning combination. This can involve changing the background color of the winning row, column, or diagonal to make the victory more noticeable and satisfying for the player. Moreover, ensuring that the game provides a clear call to action, such as a button to restart or exit the game, can improve the flow and engagement for users. Implementing the winner check in Flutter, how the game logic works. When building a tic-tac-toe game in Flutter, the implementation of the winner checking function is fundamental to ensuring that the game runs smoothly. The goal of this function is to evaluate the state of the game board after each move, check all possible winning combinations, and return a result indicating whether a player has won, or if the game is still ongoing. This process involves interacting with Flutter's reactive framework to update the user interface based on the current game state, which is updated as players take turns. In a typical Flutter implementation, the board is represented by a 3x3 matrix. This matrix could be constructed using a 2D list or a simple one-dimensional list with 9 elements. Each element of the list corresponds to a cell on the board and holds a value representing the current state of that cell, either X, O, or null if it's empty. Flutter's reactive state management system allows the game to check the board state each time a player makes a move and updates the UI to reflect this. After each move, the first task of the winner checking function is to evaluate the state of the board to see if any of the 8 possible winning lines contain 3 identical marks. This evaluation is essential after every player's move, as the board state is continually changing. The function first checks the rows, one by one, comparing the values of the cells in each row. For example, in the first row, the function checks the cells at positions 0, 0, 0, 1, and 0, 2. If all 3 cells contain the same mark, either X or O, the game declares the player associated with that mark as the winner. The function then repeats this process for the 3 columns of the grid. It checks if all the cells in each column contain the same value, ensuring that the player has aligned their marks vertically. Finally, the function evaluates the 2 diagonals, one running from the top left to the bottom right of the grid, and the other from the top right to the bottom left. If any of these diagonals contains 3 identical marks, a winner is declared. Once the winner checking function detects a winner, it is essential to stop further checks and update the game state. The game should notify the players that the game is over, and no further moves should be allowed. To implement this, the winner checking function must be designed to break out of any further checks once a winner is found. If no winner is found after evaluating all possible lines, the game should continue and allow the next player to take their turn. Managing the game state efficiently is critical when implementing the winner checking logic. The game should maintain variables or flags that track whether a player has won or if the game is a draw. Once the winner checking function detects a win or a draw, these flags should be updated accordingly, and the game should cease further moves. The UI should then reflect the game's outcome, displaying an appropriate message to the players and giving them the option to restart the game or end the session. In Flutter, updating the UI in response to game state changes is straightforward thanks to the framework's built-in state management capabilities. When a move is made, the game board is updated, and the winner checking function is invoked. Based on the result, the UI is refreshed to either highlight the winning combination or display a message announcing the draw. The ability to trigger these updates in real time is one of the key strengths of using Flutter for game development. Another important consideration is handling edge cases. For instance, if the game ends in a draw, the game should check whether all cells on the board have been filled. This check is necessary because the game can end in a draw only when all spaces are filled, and no player has won. Once the game determines that all cells are filled and no winner exists, it should notify the players that the game has ended in a draw. This ensures that the game remains responsive and handles every possible scenario, giving players a satisfying conclusion to their game experience. Game over in Tic Tac Toe, recognizing when the game ends. The concept of game over in Tic Tac Toe is central to the gameplay experience. After a player places their mark on the board, it is crucial for the game to recognize when the game has ended, either because a player has won or because the game has ended in a draw. The game over detection mechanism is responsible for halting the game and notifying the players of the result. This function is essential in ensuring that the game concludes in a timely and satisfying manner, allowing players to understand when the game has finished and providing them with options to restart or exit the game. In Tic Tac Toe, there are two main scenarios that result in the game being over. The first scenario is when a player wins by aligning 3 of their marks in a row, column, or diagonal. Once a player achieves this, the game should immediately end, and the winning player should be declared. The second scenario is when the game ends in a draw, which happens when all cells on the board are filled, but no player has won. This occurs when there are no more valid moves available, and the game must notify the players that the match has resulted in a tie. To implement the game over detection logic, the first step is checking for a winner after every move. If a winner is found, the game should immediately end, and no further moves should be allowed. This is relatively simple, as the winner checking function can trigger the game over condition when a winning combination is found. However, detecting a draw requires a bit more logic. A draw is only possible when all cells on the board are filled, and no winner has been determined. Therefore, the game needs to evaluate whether every cell has been filled and check if any of the 8 potential winning combinations contain 3 identical marks. If no winner is found and all cells are filled, the game should notify the players that the game has ended in a draw. Once the game over condition is met, whether by a win or a draw, the game should stop accepting further moves. The UI should immediately update to reflect the result, either by announcing the winner or declaring a draw. Additionally, players should be given the option to restart the game or exit. This functionality is crucial for providing a seamless and enjoyable gaming experience. The concept of resetting the game board is a fundamental aspect of any tic-tac-toe game, as it allows the game to be played multiple times without requiring the user to refresh or restart the application. The ability to reset the game board ensures that the game remains engaging and functional by giving the players an opportunity to start fresh after each game. It also maintains the game flow by allowing players to immediately play again after a victory, a tie, or even a game that ended due to some unexpected event, such as a system crash or error. In a Flutter-based tic-tac-toe game, implementing a smooth and efficient game reset mechanism is essential for providing a seamless user experience. To understand the process of resetting the game board, it's important to first look at the underlying structure of the game. Typically, the game board is represented by a list or array, where each element corresponds to a cell in the 3x3 grid of the tic-tac-toe board. The values of these elements are initially empty, but as players make their moves, they are filled with either an X or an O to represent the player's move. Once a player has won or the game has ended in a tie, the game board should be reset to its initial state, clearing out all the moves and allowing for a fresh round of gameplay. In Flutter, the game state can be managed effectively using stateful widget and the setState method. A stateful widget allows the game's UI to respond to changes in its state, which includes updating the game board and displaying the new state whenever a player makes a move or the game ends. When implementing the reset functionality, one would typically define a method to reset the game board state. This method would clear the game board array, reset any other related variables, such as the current player, the game status, and the score, and then call setState to trigger a rebuild of the UI, thus reflecting the game's reset. The actual process of resetting the game board involves setting all of the elements of the game board array back to their initial empty state. Since the game board array typically has 9 positions, one for each cell in the 3x3 grid, this can be achieved by simply assigning each element of the array back to an empty value, such as null or an empty string. Once this is done, any UI elements that display the state of the game board, such as buttons or icons representing the cells, must also be updated to reflect the new empty state. In addition to resetting the game board itself, it is important to manage other variables associated with the game, such as the current player, the winner, or whether the game has ended. If the game involves alternating between two players, such as player X and player O, the reset function should also ensure that the player turn is reset to the initial player, example player X. Moreover, if the game keeps track of a score, that score might need to be reset as well to reflect the beginning of a new game. The status of the game, whether it's ongoing, won, or tied, should also be reset, so that the game can correctly handle subsequent moves and determine the result of the next game. When implementing the reset game logic, developers must also consider what happens after the game ends. In many cases, after a player wins, a tie occurs, or a player chooses to manually reset the game, the interface may display a message congratulating the winner or notifying the players of the tie. After the message is displayed, the reset functionality should be easily accessible to allow the players to continue. A button or prompt, such as a play again or reset game button, can be provided, which, when clicked, will trigger the reset of the game board. It's crucial that this button is placed in an intuitive location within the UI, making it easy for players to know where to click next. Another important aspect of the reset functionality is ensuring that the reset process is quick and efficient, with minimal delays. If there is any noticeable lag or delay when resetting the game board, it can cause frustration and hinder the flow of the game. In some cases, players may become disoriented or impatient if the reset function takes too long to execute, which could negatively impact the overall user experience. To prevent such issues, the reset function should be lightweight and not require excessive processing power. By ensuring that the reset function executes quickly, the game remains fluid, and players can seamlessly transition from one round to the next. From a design perspective, it's important that the reset process be accompanied by visual feedback to indicate that the game has indeed been reset. For example, the reset button could change its label to New Game or display a loading animation as the game prepares to restart. These visual cues help ensure that players are aware of the reset process and prevent any confusion about the game's current state. Furthermore, if the game includes animations or visual effects, such as showing a celebratory animation when a player wins, those should be cleared or reset as well, so they do not persist after the game has ended. The reset function should ensure that everything is returned to its default state, including any animations or UI elements that were triggered during gameplay. To add an extra layer of polish to the reset functionality, you can also include a confirmation step before the game is reset, particularly if the user has not explicitly chosen to reset the game. For instance, if a player clicks the reset button after a game has ended, it may be beneficial to display a confirmation dialog that asks, "Are you sure you want to reset the game?" This can prevent accidental resets, ensuring that players have control over the action. However, this confirmation step should not be too intrusive and should not interrupt the natural flow of the game, so it's important to design it in a way that feels intuitive and quick. An important consideration when implementing the reset game board logic is ensuring that the game state persists appropriately across different sessions, particularly in cases where players may leave the game and return later. If the reset logic does not properly clear the game state, players may return to a game that appears to be stuck, leading to confusion. To address this, the game should implement a reliable mechanism for clearing all game-related data, both in memory and in any persistent storage, such as shared preferences or local storage, to avoid any conflicts or inconsistencies. The reset logic also extends to handling edge cases where the game might crash, freeze, or become unresponsive. In such cases, a robust reset mechanism is essential to allow the player to easily recover from these issues. This might involve implementing automatic resets in certain situations, such as when the game crashes, or providing an easily accessible button to restart the game manually. Regardless of the situation, the reset process should always be reliable, ensuring that players can resume or restart their game with minimal disruption. Lastly, testing the reset functionality is crucial to ensuring a smooth user experience. Developers should test the reset logic across a variety of scenarios, such as when the game is won, tied, or manually reset, to make sure that the game board is correctly cleared and the game can be played again. Additionally, edge cases, such as rapid clicking of the reset button or returning to the game after a crash, should be tested to ensure that the reset process remains stable and consistent under various conditions. Once the player has won in a tic-tac-toe game, it's not enough to simply display a basic message. The winning message should be an experience in itself, capturing the emotion of the victory while integrating seamlessly with the rest of the game. In this paragraph, we'll delve deeper into how to design and implement a winning message that feels impactful, ensuring that it aligns with the game's overall flow and user expectations. The psychological impact of a winning message. A well-designed winning message in a game can significantly affect the player's emotional experience. When a player wins, they often feel a sense of accomplishment and pride. The message displayed should reflect this emotion and amplify it. For example, the tone of the message should be positive, celebratory, and engaging. Score increase in a tic-tac-toe game. The concept of score increase is integral to any competitive game as it helps track a player's success and performance over time. In tic-tac-toe, score serves to quantify the outcomes of each round, typically assigning a point to the winner. The objective of incorporating a scoring mechanism is to provide players with a tangible sense of progress and achievement during the game. This can be particularly useful when the game spans multiple rounds, creating a competitive environment where players are incentivized to win more rounds. To begin with, a scoring system in tic-tac-toe is usually quite simple. Each round of the game results in a winner, or sometimes a draw, and the winner's score is incremented. In a typical single-round game, the score increases by 1 for the winning player, while the losing player receives no points for that round. If the game ends in a draw, neither player's score increases. This clear and simple system helps to maintain the focus on the gameplay itself without overcomplicating things. The importance of score tracking in a game is not limited to showing who is winning. It also serves to enhance the overall player experience. For example, displaying a running score helps to establish a sense of competition, motivating players to keep playing and strive for victory. Without a score system, tic-tac-toe could feel like an endless sequence of isolated games without any meaningful progression or sense of accomplishment. In terms of Flutter implementation, the game state needs to be managed carefully to track and update the score after each round. Flutter provides various tools for managing state, whether it's simple state management through the setState method or more sophisticated solutions like Provider or Block. The score needs to be incremented when a player wins, and this can be easily done by checking the outcome of the game after each round. The score variable must be updated and the user interface, UI, needs to reflect the new score promptly. A visual display of the score, perhaps at the top or bottom of the screen, can be employed to keep players informed throughout the game. One of the critical aspects of the score increase is how it is visualized. It is not enough for the game to simply update the score in the background. The score should be shown clearly on the screen for players to see. Typically, this involves using basic Flutter widgets such as text, which can dynamically display the current score of each player. As each round concludes, the score should update to reflect the result, giving players real-time feedback on how they're progressing through the game. A constantly visible score system can also serve to enhance the game's competitive feel, encouraging players to push harder for a win. The handling of ties or draws also plays an important role in the score increase logic. Since a draw results in no increase in score, the game needs to recognize when a tie occurs. This could happen if all spaces on the board are filled and no player has achieved a winning line. In this case, the score should remain unchanged, but the game still needs to communicate this outcome to the players. Often, a message such as "it's a tie" will be shown, reminding players that while no one won, the round is over, and they can start a new round if they wish. Overall, adding a score increase mechanism to Tic Tac Toe not only tracks who wins each round but also adds a sense of achievement and progression to the game. Players can compare scores after several rounds, creating a more engaging experience. This system transforms the game from a simple, one-off experience into a more competitive environment, where winning and losing take on more significance. The incorporation of such a system can significantly elevate the overall player experience in Tic Tac Toe. Another important consideration for the score increase mechanism is how the game can handle different game modes or difficulty levels. In certain Tic Tac Toe variants, such as a tournament-style game, a player's score could be accumulated across multiple rounds, often referred to as a series of games. This type of system is especially useful when players aim to win a series rather than a single round. For example, in a two-player series, the first player to win a predetermined number of rounds, such as 5, would be declared the overall winner. In such cases, keeping track of the cumulative score and dynamically updating it throughout the series adds another layer of complexity to the score increase system. In a scenario where multiple rounds are being played, it's important to ensure that the score system resets after each round and that the scores from previous rounds are tallied appropriately. This will require careful management of the game state, with a reset function that clears out the board and prepares for the next round while retaining the cumulative score for both players. Additionally, the game must provide an easy way to track who is leading and how many games each player has won in the series. This can be done by displaying both the individual game score and the series score side by side, allowing players to gauge their progress throughout the session. It is also worth noting that the score display should be flexible enough to handle different configurations. For example, the game may allow players to choose the number of rounds they wish to play in advance, and the score display must accommodate this change by showing the current round out of the total number of rounds selected. Such flexibility enhances the user experience, as players can see not only their score but also how many rounds remain in the current session. This also helps to create a sense of anticipation as players approach the final rounds of the game, with their scores hanging in the balance. To make the score increase system even more engaging, a Flutter Tic Tac Toe game could incorporate visual feedback mechanisms when the score increases. This could involve animations, sounds, or changes in the appearance of the score text to give players a sense of reward. For example, when a player's score increases, the game could display a visual cue like a subtle animation or a glowing effect on the score, indicating the player's progress. These small but impactful details improve the user experience and make the game feel more rewarding. Finally, it is essential to address the case when the game ends in a draw. Since no score increases occur in the event of a tie, the system should still offer some form of closure to players. The game could display a message such as "Good game," or "It's a tie," and encourage players to start a new round. This provides a psychological incentive for players to continue playing, as the game maintains a positive, motivational atmosphere even after a draw. Additionally, players should be able to quickly reset the game and resume playing, preventing frustration or stagnation. Game over logic in a tic-tac-toe game. The game over logic in tic-tac-toe serves to determine when the game should end and what the outcome is. Tic-tac-toe is a relatively simple game, but the game over logic plays a crucial role in managing the flow of the game and ensuring that players are aware of the outcome, whether it is a win, loss, or draw. This logic encompasses several key scenarios: detecting when a player wins, identifying a draw, and handling the transition to the end of the game. Once the game reaches a conclusion, the game over logic must trigger the appropriate actions, including notifying the players of the result and providing options to start a new game. The most common and straightforward condition for a game to be over in tic-tac-toe is when one of the players achieves a victory. This occurs when a player places 3 of their marks, either X or O, consecutively in a row, column, or diagonal. The detection of this winning condition is a fundamental part of the game over logic. Once a player's marks are aligned, the game must recognize this and end the current round, declaring the winner. Without this mechanism, the game would fail to acknowledge the player's success, leaving players confused about whether they've won or not. Another significant game over condition is a tie or draw. A draw happens when the game board is completely filled, but no player has succeeded in creating a winning line. It's important for the game over logic to properly detect this condition as well. Since a draw doesn't have a winner, it requires a different handling approach compared to a regular win. In the case of a tie, the game needs to inform the players that no one won the round, and the game has ended in a draw. The game can then reset or allow the players to continue with a new round if they choose. One of the main challenges in implementing game over logic is ensuring that the game over state is detected at the right time. This requires continuously monitoring the game board after every move to check for a winner or a draw. As the game progresses, the state of the board changes, and the game over logic must be able to recognize the moment when the game should end. This can involve checking every row, column, and diagonal after each move to ensure that no further moves are necessary once a winner is found or when the board is filled. The game over logic also needs to be seamless and responsive, providing a smooth transition when the game ends. When a player wins, the game should immediately end, displaying a congratulatory message to the winner and offering the option to start a new game. Similarly, when the game ends in a draw, the system should display a message indicating that the game is a tie and provide the option to restart. Adding a timer to a game like tic-tac-toe can significantly transform the gameplay experience, adding a layer of excitement and competition that wouldn't be present in a standard, untimed version of the game. While tic-tac-toe is traditionally a quick game, with no time pressure on the players, the introduction of a timer creates a dynamic shift that elevates the game into something more engaging and strategic. The key change here is that players no longer have the luxury of taking as long as they need to decide on their moves. Instead, they are forced to make quick decisions within a set time limit, which adds a level of urgency to the game. The timer not only affects how players approach the game but also creates a sense of psychological pressure. This pressure can lead to more intense gameplay, where players must balance the speed of their decision-making with the strategies they want to implement. The time limit on each turn forces players to think on their feet, sometimes making split-second decisions that might not be as thoroughly planned as they would be in an untimed game. This can lead to a more exciting experience, as the quick-paced nature of the game heightens tension and makes every move more significant. Even though tic-tac-toe is a simple game at its core, the introduction of a timer can make it feel like a high-stakes competition, especially when players are under pressure to act quickly. Furthermore, Adding a timer introduces an element of fairness into the game. In a traditional tic-tac-toe setup, there's often a significant advantage for players who tend to deliberate longer over their moves, especially if their opponent is quicker or more impulsive. With a timer in place, both players are forced to play within the same time constraints, which ensures that no one has an unfair advantage due to their decision-making pace. This leveling of the playing field can make the game feel more balanced and equitable, fostering a competitive spirit that might be lacking in the original, slower-paced format. Players are encouraged to rely not only on their strategic thinking but also on their ability to manage their time effectively. The timer doesn't just add pressure, it also adds an element of skill, where managing one's time becomes an essential part of the game. A timer also ensures that the game keeps moving forward at a steady pace. Without a time constraint, players might find themselves lingering on decisions, taking longer than necessary for each move, and potentially drawing out the game unnecessarily. This can sometimes lead to frustration, especially if the game goes on for longer than expected. By adding a timer, each turn has a defined beginning and end, which keeps the game flowing smoothly. A well-placed timer also ensures that the game doesn't become stagnant or lose momentum, maintaining a brisk and engaging pace that keeps both players involved. The ticking clock adds an underlying sense of urgency, prompting players to make their decisions quickly, without overthinking. In addition to making the game more competitive and dynamic, a timer can also increase replay value. With each game, players are faced with the challenge of adapting to a limited time frame, meaning that no two games will be exactly alike. The variability in how quickly a player can think and act creates a wide range of possible outcomes, adding an unpredictable and exciting element to each match. This unpredictability keeps players engaged and invested in the game, as they are always challenged to think quickly and adapt to their opponent's strategies. The timer can also be a fun way to spice up multiplayer sessions, adding a shared experience of stress and excitement that both players can enjoy. When implementing a timer into tic-tac-toe, there are various options for customizing the timer to fit the preferences of the players. For instance, some games might have a fixed time limit per turn, while others might offer a countdown for the entire match. A fixed timer ensures that players stay within a set pace, regardless of the situation, while a countdown for the entire match could create an overall sense of time pressure, forcing players to make quicker decisions as they race to finish the game. Depending on the timer settings, players might also have the option to pause or extend their time if needed. Having flexibility in how the timer works can add further customization to the game, giving players control over their experience while still maintaining the core element of time pressure. Adding a timer in tic-tac-toe also introduces the potential for timed tournaments and competitive play, where players can go head-to-head in fast-paced matches that emphasize both strategy and speed. In such settings, the timer becomes an integral part of the competitive atmosphere, ensuring that all players have the same constraints and adding an extra layer of excitement to the event. Tournament-style play, in particular, thrives under timed conditions, as it allows multiple rounds to take place in a limited amount of time, without the game dragging on. A well-managed tournament with a timer can foster an intense and fun environment, where the stakes are higher and every second counts. On a broader level, the introduction of a timer in tic-tac-toe can serve as a valuable lesson for both developers and players. For developers, adding a timer introduces a new layer of technical complexity, requiring careful consideration of how the timer functions within the game. There are practical concerns, such as how the timer interacts with the game board, how it communicates with players, and how to ensure it doesn't interfere with the flow of the game. Managing the countdown, resetting the timer when needed, and displaying it clearly to the player are just some of the challenges that need to be addressed. For players, the timer serves as a way to enhance their cognitive skills, encouraging quick thinking, decision-making under pressure, and time management. This makes the game more than just a casual pastime. It becomes an exercise in mental agility and focus, providing both entertainment and a challenge. Ultimately, the inclusion of a timer in Tic Tac Toe makes the game more exciting, competitive, and engaging. It introduces a new level of urgency that enhances the overall experience for players, pushing them to think quickly, make snap decisions, and compete against the clock as much as their opponent. The timer not only adds tension and excitement but also promotes fairness by ensuring that all players are held to the same time standards. Whether it's a casual match between friends or a more intense competitive session, the timer transforms Tic Tac Toe into a game of strategy, speed, and mental agility. Enhancing the user interface, UI, of a game like Tic Tac Toe is one of the most impactful ways to improve the overall player experience. While Tic Tac Toe is simple in terms of gameplay mechanics, the visual and interactive elements of the game can significantly shape how enjoyable the game is to play. A well-designed UI is not just about making things look appealing, but about improving the usability, engagement, and clarity of the game, ensuring that players can easily navigate and interact with it. A great UI makes the game feel polished, professional, and immersive, all while maintaining a balance between functionality and aesthetics. The UI of a Tic Tac Toe game is often the first thing a player notices when they start the game. The design choices, colors, fonts, and overall layout all play a significant role in creating a positive first impression. A clean and minimalist UI can make the game feel more inviting, as it ensures that players are not overwhelmed by excessive clutter or confusing elements. In contrast, a poorly designed UI with too many competing visual elements can detract from the experience, leaving players frustrated or confused. For example, the Tic Tac Toe grid itself should be visually clear, with enough contrast between the X's and O's and the background, ensuring that players can easily identify the current state of the game. In addition to visual appeal, the UI should be user-friendly and intuitive. Every interaction should feel natural and easy to understand. Buttons should be clearly labeled, and actions like starting a new game, restarting the board, or viewing the score should be simple to access. This ensures that players don't have to spend time figuring out how to perform basic tasks, allowing them to focus on the game itself. The placement of elements, such as the game's score, the player's turn indicator, and the timer, if included, should be logically organized, preventing clutter and ensuring that players can easily find what they need without feeling lost. When a player can quickly figure out how to navigate through the interface, it improves their overall experience and makes the game feel more accessible. Animation is another powerful tool in enhancing the UI of Tic Tac Toe. Smooth, subtle animations can bring a sense of life to the game. Game over when time's up. In the world of game development, particularly for puzzle games like Tic Tac Toe, the challenge often lies not just in the basic mechanics but in adding features that elevate the user experience. One such feature that can make your Tic Tac Toe game stand out is a time limit for each player's turn. This feature adds a sense of urgency, ensuring the game doesn't drag on and making it more competitive. Implementing a game over when time's up mechanic in a Flutter-based Tic Tac Toe game requires understanding several components: setting a timer, monitoring the time, enforcing game logic when time runs out, and offering user feedback. To begin, the core idea behind setting a timer for each player is simple: each player is allowed a certain amount of time to make their move. If they fail to do so within the time limit, the game automatically ends, or alternatively, the turn could shift to the other player. The time limit can be as short as a few seconds or can extend to a minute, depending on how fast-paced you want the game to be. This mechanic also ensures that no player can exploit the game by taking too long to make decisions, keeping the game moving at a reasonable pace. In Flutter, you can utilize the timer class from Dart's Dart Async library to create a countdown timer. The basic functionality involves starting the timer when it's a player's turn, monitoring the countdown, and updating the user interface to show the remaining time. If the timer reaches 0 before the player makes a move, the game needs to respond accordingly. The challenge comes in how to integrate this timer with the existing game logic. First, you'll need to add a time limit that is associated with each player's turn. This could involve initializing a timer when the game starts, ensuring that the timer resets each time the turn switches between players. You would likely implement a visual countdown timer that updates dynamically on the screen, providing feedback to the players so they can track their time. A stateful widget would be ideal for this, as it allows you to update the countdown as the timer progresses. The next part is ensuring that the game knows what to do when the timer runs out. There are several options here, depending on the rules you want to enforce. One approach is to automatically skip the current player's turn and pass it to the next player when the time expires. Another approach might be to automatically declare the game over if neither player has made a move within the time limit. You could also choose to give the player a slight grace period to make their move before transitioning to the next phase of the game. User feedback is crucial in making sure players understand what's happening when the timer runs out. At the moment the timer ends, the game should immediately display a message to the player or show a pop-up indicating that the time has expired and the game has either ended or moved to the next player. For example, you could use Flutter's Show Dialog method to display a simple dialog box informing the player that their time is up. To ensure that the user is aware of the time limits, you can add a visual cue like a red background or flashing timer as a countdown reaches the final seconds, creating a sense of tension as the timer ticks down. In terms of the backend logic, this feature may seem relatively simple at first, but it requires careful attention to the state of the game. You need to account for scenarios like pausing or restarting the timer, handling edge cases, such as what happens if the player disconnects or loses network connectivity, and ensuring that the game accurately reflects changes in the timer state. For example, if the game has a networked multiplayer mode, you need to ensure that the timer runs consistently across all devices and that the game accurately synchronizes when time runs out for one player. Flutter offers several useful packages that can help you integrate time-related functionality, such as Flutter_timer or Flutter_countdown_timer. These packages make it easier to handle time-based events without having to write the entire timer logic yourself. However, you'll still need to integrate them with the rest of your game's state management and ensure the user interface reflects the ongoing countdown. In multiplayer games, especially when time limits are in place, it's important to ensure that the experience is fair for both players. For example, if a player takes too long to make their move, the game shouldn't punish them by cutting off their turn too early. Instead, you can introduce a small grace period or allow the player to restart the timer once per game, giving them a chance to recover if they were distracted or facing a momentary issue. Another aspect to consider is scalability. While this feature works for a simple, two-player tic-tac-toe game, you might want to extend the concept of time-based mechanics to other multiplayer formats or game types. For example, you could consider having different time limits for different game modes or player skill levels. More advanced settings might allow players to customize the time limit per round or add options for overtime, where each player gets an additional fixed amount of time if the game reaches a draw or tie after all rounds. Add comment to easily understand code. Commenting your code effectively is one of the most valuable practices in software development. It helps not only yourself but also others who might be working with you or reviewing your work in the future. In the case of a tic-tac-toe game built with Flutter, proper code commenting becomes even more important. As your code grows in complexity, adding clear and concise comments makes it easier to navigate, debug, and enhance the game. This section will explain how to implement comments in a Flutter-based tic-tac-toe project, ensuring that your code is not just functional but also easy to understand. The first rule of good commenting is that it should be useful. Comments shouldn't simply restate what the code is doing, instead, they should explain the why behind the code, giving context for decisions made during development. For example, when you're implementing the timer functionality discussed in the previous section, you might write a comment explaining why you chose a certain time limit for each player's turn or why you're using a specific approach to update the UI based on the timer state. Another important aspect is to comment on sections of code that are complex or non-intuitive. For instance, if you're working with advanced state management, such as using provider, riverpod, or block, comments should explain how the state is being passed and updated. This is crucial in Flutter, where the widget tree and state management can become convoluted, especially when handling dynamic updates like those triggered by the timer. Game over when time's up. In the world of game development, particularly for puzzle games like tic-tac-toe, the challenge often lies not just in the basic mechanics but in adding features that elevate the user experience. One such feature that can make your tic-tac-toe game stand out is a time limit for each player's turn. This feature adds a sense of urgency, ensuring the game doesn't drag on and making it more competitive. Implementing a game over when time's up mechanic in a Flutter-based tic-tac-toe game requires understanding several components: setting a timer, monitoring the time, enforcing game logic when time runs out, and offering user feedback. To begin, the core idea behind setting a timer for each player is simple. Each player is allowed a certain amount of time to make their move. If they fail to do so within the time limit, the game automatically ends, or alternatively, the turn could shift to the other player. The time limit can be as short as a few seconds or can extend to a minute, depending on how fast-paced you want the game to be. This mechanic also ensures that no player can exploit the game by taking too long to make decisions, keeping the game moving at a reasonable pace. In Flutter, you can utilize the timer class from Dart's Dart Async library to create a countdown timer. The basic functionality involves starting the timer when it's a player's turn, monitoring the countdown, and updating the user interface to show the remaining time. If the timer reaches 0 before the player makes a move, the game needs to respond accordingly. The challenge comes in how to integrate this timer with the existing game logic. First, you'll need to add a time limit that is associated with each player's turn. This could involve initializing a timer when the game starts, ensuring that the timer resets each time the turn switches between players. You would likely implement a visual countdown timer that updates dynamically on the screen, providing feedback to the players so they can track their time. A stateful widget would be ideal for this, as it allows you to update the countdown as the timer progresses. The next part is ensuring that the game knows what to do when the timer runs out. There are several options here, depending on the rules you want to enforce. One approach is to automatically skip the current player's turn and pass it to the next player when the time expires. Another approach might be to automatically declare the game over if neither player has made a move within the time limit. You could also choose to give the player a slight grace period to make their move before transitioning to the next phase of the game. User feedback is crucial in making sure players understand what's happening when the timer runs out. At the moment the timer ends, the game should immediately display a message to the player or show a pop-up indicating that the time has expired and the game has either ended or moved to the next player. For example, you could use Flutter's Show Dialog method to display a simple dialog box informing the player that their time is up. To ensure that the user is aware of the time limits, you can add a visual cue like a red background or flashing timer as a countdown reaches the final seconds, creating a sense of tension as the timer ticks down. In terms of the backend logic, this feature may seem relatively simple at first, but it requires careful attention to the state of the game. You need to account for scenarios like pausing or restarting the timer, handling edge cases, such as what happens if the player disconnects or loses network connectivity, and ensuring that the game accurately reflects changes in the timer state. For example, if the game has a networked multiplayer mode, you need to ensure that the timer runs consistently across all devices and that the game accurately synchronizes when time runs out for one player. Flutter offers several useful packages that can help you integrate time-related functionality, such as Flutter_timer or Flutter_countdown_timer. These packages make it easier to handle time-based events without having to write the entire timer logic yourself. However, you'll still need to integrate them with the rest of your game's state management and ensure the user interface reflects the ongoing countdown. In multiplayer games, especially when time limits are in place, it's important to ensure that the experience is fair for both players. For example, if a player takes too long to make their move, the game shouldn't punish them by cutting off their turn too early. Instead, you can introduce a small grace period or allow the player to restart the timer once per game, giving them a chance to recover if they were distracted or facing a momentary issue. Another aspect to consider is scalability. While this feature works for a simple, two-player tic-tac-toe game, you might want to extend the concept of time-based mechanics to other multiplayer formats or game types. For example, you could consider having different time limits for different game modes or player skill levels. More advanced settings might allow players to customize the time limit per round or add options for overtime, where each player gets an additional fixed amount of time if the game reaches a draw or tie after all rounds. Add comment to easily understand code. Commenting your code effectively is one of the most valuable practices in software development. It helps not only yourself but also others who might be working with you or reviewing your work in the future. In the case of a tic-tac-toe game built with Flutter, proper code commenting becomes even more important. As your code grows in complexity, Adding clear and concise comments makes it easier to navigate, debug, and enhance the game. This section will explain how to implement comments in a Flutter-based tic-tac-toe project, ensuring that your code is not just functional but also easy to understand. The first rule of good commenting is that it should be useful. Comments shouldn't simply restate what the code is doing. Instead, they should explain the why behind the code, giving context for decisions made during development. For example, when you're implementing the timer functionality discussed in the previous section, you might write a comment explaining why you chose a certain time limit for each player's turn or why you're using a specific approach to update the UI based on the timer state. Another important aspect is to comment on sections of code that are complex or non-intuitive. For instance, if you're working with advanced state management, such as using provider, riverpod, or block, comments should explain how the state is being passed and updated. This is crucial in Flutter, where the widget tree and state management can become convoluted, especially when handling dynamic updates. Hello guys, in this video we are enhancing the user interface, UI, of a tic-tac-toe game. Can be a transformative process, as it is not only about improving the visual appeal but also ensuring that the game becomes more engaging, intuitive, and accessible for players. This process begins by evaluating the current design of the game, understanding how users interact with it, and identifying areas for improvement. By improving elements such as layout, colors, fonts, buttons, and overall interaction flow, you can create a more appealing and enjoyable experience for users. It is important to consider the type of users that will interact with the game, as well as the platform they will use, be it desktop, mobile, or web. This evaluation forms the foundation for improving the user interface in ways that resonate with both casual and more dedicated players. The goal should always be to create a smoother, more enjoyable experience that enhances the gameplay, while making the game's design visually engaging. One of the first and most significant areas of improvement for the tic-tac-toe UI is the game board itself. The default layout often consists of a basic grid with simple X and O markings. While functional, this design is quite bare and can be enhanced through customization. Adding smoother lines and more vibrant colors to the grid can help bring attention to the game area. Instead of traditional straight lines, a modern UI may opt for rounded edges, subtle animations, or even dynamic borders that highlight the current move or state of the game. These enhancements can also introduce a sense of interaction. For example, when a player clicks or taps on a space, the grid can visually respond with a ripple effect or a gentle zoom. A more polished game board design can contribute to a more inviting and professional user interface, giving players the impression that they are engaging with a modern, thoughtfully designed app. When considering how to improve the UI of a tic-tac-toe game, color plays a critical role in creating an immersive experience. Colors not only define the aesthetic of the game but also influence the mood and emotions of the player. For instance, bright and playful colors may make the game feel more casual, whereas more subdued or contrasting colors could make the game feel more competitive. The use of color should be deliberate, ensuring it is in harmony with the overall theme. For instance, adding a custom color palette can break away from the typical black and white grid, offering different themes such as vibrant hues, pastels, or even dark mode for players who prefer low-light environments. Moreover, colors can be used effectively to indicate the state of the game, such as highlighting the winning combination with a color change or signaling a draw with a distinct shade. By considering color psychology, the UI can elicit different feelings in the player, such as excitement, focus, or relaxation, making the game more emotionally engaging. Typography also plays a major role in enhancing the user interface of a tic-tac-toe game. The choice of font can contribute significantly to the overall feel and usability of the game. While a simple font might suffice, using a font that is modern, easily readable, and even playful can make the game feel more personalized and fun. It's important to ensure that the font is large enough to be easily read on all devices and screen sizes. Additionally, you can experiment with different font weights, such as bold for the X and O markers, to make the characters stand out more clearly. Fonts should also be consistent with the theme of the game, and it can be useful to implement dynamic fonts, where the size or style changes based on the game state. For example, the font can grow when the player is on a winning streak or shrink if the game is nearing its end. Such subtle adjustments create a sense of progression and reward within the interface. Another aspect of UI enhancement is improving the game's controls and interaction elements. In a simple game like Tic Tac Toe, the game's control elements usually consist of the grid spaces and possibly a few buttons, such as restart or exit. However, these can be made more intuitive and accessible through thoughtful design. The use of large, easy-to-click buttons, even in smaller mobile devices, ensures players don't have difficulty interacting with the game. Additionally, interactive elements such as an animated Start New Game button or a confirmation dialog for restarting the game can add a layer of polish. Introducing game menus or settings that allow users to choose difficulty levels, themes, or sound effects can also enhance the player experience. This added complexity, if implemented with ease of use in mind, makes the interface feel more comprehensive without overwhelming the user. Animations are another critical enhancement that can improve the visual appeal and user experience of a tic-tac-toe game. Simple animations, such as moving the X or O markers into place with smooth transitions, create a more satisfying and fluid experience for players. Animation can also be applied to the game's win condition, where the winning row, column, or diagonal line could animate in a way that draws attention to the accomplishment. Moreover, an animated background that subtly shifts in color or changes based on the game state adds a layer of dynamism to the design. Transition animations between game states, such as when a player wins, or a new round begins, can make the overall game feel less static and more lively. These animations not only make the game visually appealing but also reinforce the sense of progression, offering immediate feedback to the player. In addition to visual enhancements, accessibility is a critical component when redesigning the UI of tic-tac-toe. Accessibility ensures that all players, regardless of their abilities, can enjoy the game. This can be achieved by implementing features such as adjustable font sizes, color contrast options, and alternative text descriptions for visually impaired players. Additionally, voice feedback can be integrated, allowing players to receive auditory cues when placing their moves or when the game state changes. This is particularly important for players who have difficulty seeing or reading text on the screen. It's also essential to consider keyboard or gesture controls for users with physical disabilities, making sure the game is playable without relying solely on mouse clicks or taps. By adding accessibility features, you ensure that the game is inclusive, appealing to a broader audience. One of the more advanced UI enhancements for tic-tac-toe involves integrating multiplayer functionality, either locally or online. If the game offers an online multiplayer mode, the interface should be designed to seamlessly handle the interaction between players. This can include a real-time scoreboard, player avatars, or chat functionality for communication. A lobby system could also be implemented where players can search for matches, invite friends, or join random games. The multiplayer interface should focus on ease of use, allowing players to easily navigate between different game modes and matches. To avoid cluttering the screen, pop-up notifications or a side panel could be used to display relevant information like match status or player statistics. In this way, the interface adapts to support both solo and multiplayer experiences, making the game feel more robust and community-oriented. A crucial aspect of UI enhancement for tic-tac-toe is incorporating feedback loops and error handling within the game. Players should receive clear, intuitive feedback on their actions. Flutter packages are essential tools that extend the capabilities of the Flutter framework, allowing developers to integrate pre-built functionalities into their applications without reinventing the wheel. These packages, created by the Flutter community and Google, cover a wide range of features, such as UI components, state management, animations, and backend integrations. By leveraging packages, developers can save time, reduce errors, and focus on building unique aspects of their apps. Packages are designed to be modular, making them easy to add or remove, and they follow Flutter's standards to ensure compatibility. This ecosystem of reusable code is one of Flutter's biggest strengths, enabling rapid development and fostering collaboration among developers worldwide. PUBDev is the official repository for Flutter and Dart packages, serving as a central hub where developers can discover, share, and manage dependencies for their projects. It hosts thousands of packages, each accompanied by documentation, version history, and user reviews, making it easier to evaluate their suitability. Developers can search for packages based on categories, popularity, or specific use cases, ensuring they find the right tools for their needs. PUBDev also provides critical metrics like package health, which assesses code quality, maintenance, and adherence to best practices. By streamlining package management, pub.dev simplifies the process of integrating third-party code, ensuring projects remain organized and dependencies are up to date. The Confetti package is a popular Flutter library designed to create celebratory animations, such as particle effects resembling confetti bursts, often used to celebrate user achievements or game victories. It offers customizable parameters like colors, shapes, emission duration, and directional controls, allowing developers to tailor animations to their app's theme. The package uses Flutter's rendering engine to ensure smooth performance across devices, even with complex animations. Its simplicity and visual appeal make it ideal for gaming apps, fitness trackers, or educational platforms where rewarding users enhances engagement. By integrating the Confetti package, developers can add a touch of delight to their apps with minimal effort. When using Flutter packages, developers rely on pub.dev's robust infrastructure to manage dependencies through the pubspec.yaml file. This file lists all packages and their versions, ensuring consistency across development environments. PUBDev's versioning system helps avoid conflicts by allowing developers to specify version constraints, reducing the risk of breaking changes. Regular updates to packages are tracked on pub.dev, and developers can migrate to newer versions using detailed migration guides provided by maintainers. This system promotes stability and security, as outdated or vulnerable packages can be easily identified and updated, maintaining the app's reliability over time. The Confetti package's flexibility extends to its ability to simulate realistic physics, such as gravity, wind, and particle spread, making animations feel dynamic and lifelike. Developers can trigger confetti effects programmatically, such as after a user completes a level in a game or achieves a personal milestone. The package also supports multiple simultaneous bursts, enabling complex celebratory sequences. Since it's open source, developers can modify the source code to create unique variations, though the default settings are often sufficient for most use cases. Its lightweight nature ensures it doesn't bloat the app, making it a practical choice for performance-conscious projects. PUBDev's scoring system evaluates packages based on factors like documentation quality, code health, and platform support, guiding developers toward reliable solutions. High-quality packages often receive verified publisher or Flutter favorite badges, signaling trustworthiness. Developers can contribute to packages by reporting issues, suggesting features, or submitting pull requests, fostering a collaborative environment. PUBDev also highlights trending packages, helping the community stay updated on emerging tools. This ecosystem encourages innovation, as developers build upon existing packages to create specialized solutions, reducing duplication of effort and accelerating the development life cycle. Integrating the confetti package involves adding it to the pubspec.yaml file and importing it into the relevant Dart files. Developers can then use the provided widget or controller to manage animation states, such as starting or stopping the effect. Customization options include adjusting colors to match the app's branding, changing particle shapes to stars or hearts, and controlling the emission area on the screen. The package's documentation offers clear examples, making it accessible even to those new to Flutter. By following best practices, such as limiting active animations during low-performance scenarios, developers ensure smooth user experiences. PUBDev's role in the Flutter ecosystem cannot be overstated. It acts as a bridge between package creators and consumers, ensuring a seamless exchange of tools. Developers publishing packages on pub.dev must adhere to guidelines that emphasize clarity, proper licensing, and thorough documentation. The platform also supports private packages for teams needing restricted access, catering to enterprise environments. As Flutter grows, pub.dev continues to evolve, adding features like automated security scans and dependency graphs, further solidifying its position as an indispensable resource for developers. The confetti package exemplifies how niche utilities can significantly enhance user experience. Beyond games, it can be used in e-commerce apps to celebrate purchases, in social media platforms for milestone notifications, or in productivity apps to mark task completion. Its versatility stems from Flutter's cross-platform nature, ensuring consistent animations on iOS, Android, and the web. By incorporating such engaging elements, apps can foster emotional connections with users, increasing retention and satisfaction. The package's ongoing updates and community support ensure it remains compatible with the latest Flutter versions, future-proofing its utility. The confetti package exemplifies how subtle animations can elevate user engagement by turning mundane interactions into memorable experiences. Designed to simulate festive particle effects, it is often used in gaming apps to celebrate victories or in fitness apps to reward milestones, creating a sense of accomplishment. The package leverages Flutter's animation APIs to generate bursts of confetti with customizable properties like color gradients, shapes, example circles, hearts, and movement patterns influenced by simulated physics. Developers can adjust parameters such as gravity, emission speed, and wind direction to create effects that align with their app's aesthetic, whether whimsical confetti showers in a children's app or sleek, minimalist bursts in a productivity tool. Performance optimization is a key consideration. The package efficiently manages rendering to avoid frame drops, even on lower-end devices. Its event-driven design allows animations to trigger on specific user actions, such as completing a purchase or achieving a high score. Flutter packages are essential tools that extend the capabilities of the Flutter framework, allowing developers to integrate pre-built functionalities into their applications without reinventing the wheel. These packages, created by the Flutter community and Google, cover a wide range of features, such as UI components, state management, animations, and backend integrations. By leveraging packages, developers can save time, reduce errors, and focus on building unique aspects of their apps. Packages are designed to be modular, making them easy to add or remove, and they follow Flutter's standards to ensure compatibility. This ecosystem of reusable code is one of Flutter's biggest strengths, enabling rapid development and fostering collaboration among developers worldwide. PUBDev is the official repository for Flutter and Dart packages, serving as a central hub where developers can discover, share, and manage dependencies for their projects. It hosts thousands of packages, each accompanied by documentation, version history, and user reviews, making it easier to evaluate their suitability. Developers can search for packages based on categories, popularity, or specific use cases, ensuring they find the right tools for their needs. PUBDev also provides critical metrics like package health, which assesses code quality, maintenance, and adherence to best practices. By streamlining package management, pub.dev simplifies the process of integrating third-party code, ensuring projects remain organized and dependencies are up to date. The Confetti package is a popular Flutter library designed to create celebratory animations, such as particle effects resembling confetti bursts, often used to celebrate user achievements or game victories. It offers customizable parameters like colors, shapes, emission duration, and directional controls, allowing developers to tailor animations to their app's theme. The package uses Flutter's rendering engine to ensure smooth performance across devices, even with complex animations. Its simplicity and visual appeal make it ideal for gaming apps, fitness trackers, or educational platforms where rewarding users enhances engagement. By integrating the Confetti package, developers can add a touch of delight to their apps with minimal effort. When using Flutter packages, developers rely on pub.dev's robust infrastructure to manage dependencies through the pubspec.yaml file. This file lists all packages and their versions, ensuring consistency across development environments. PUBDev's versioning system helps avoid conflicts by allowing developers to specify version constraints, reducing the risk of breaking changes. Regular updates to packages are tracked on pub.dev, and developers can migrate to newer versions using detailed migration guides provided by maintainers. This system promotes stability and security, as outdated or vulnerable packages can be easily identified and updated, maintaining the app's reliability over time. The Confetti package's flexibility extends to its ability to simulate realistic physics, such as gravity, wind, and particle spread, making animations feel dynamic and lifelike. Developers can trigger confetti effects programmatically, such as after a user completes a level in a game or achieves a personal milestone. The package also supports multiple simultaneous bursts, enabling complex celebratory sequences. Since it's open source, developers can modify the source code to create unique variations, though the default settings are often sufficient for most use cases. Its lightweight nature ensures it doesn't bloat the app, making it a practical choice for performance-conscious projects. PUBDev's scoring system evaluates packages based on factors like documentation quality, code health, and platform support, guiding developers toward reliable solutions. High-quality packages often receive verified publisher or Flutter favorite badges, signaling trustworthiness. Developers can contribute to packages by reporting issues, suggesting features, or submitting pull requests, fostering a collaborative environment. PUBDev also highlights trending packages, helping the community stay updated on emerging tools. This ecosystem encourages innovation, as developers build upon existing packages to create specialized solutions, reducing duplication of effort and accelerating the development life cycle. Integrating the Confetti package involves adding it to the pubspec.yaml file and importing it into the relevant Dart files. Developers can then use the provided widget or controller to manage animation states, such as starting or stopping the effect. Customization options include adjusting colors to match the app's branding, changing particle shapes to stars or hearts, and controlling the emission area on the screen. The package's documentation offers clear examples, making it accessible even to those new to Flutter. By following best practices, such as limiting active animations during low-performance scenarios, developers ensure smooth user experiences. PUBDev's role in the Flutter ecosystem cannot be overstated. It acts as a bridge between package creators and consumers, ensuring a seamless exchange of tools. Developers publishing packages on pub.dev must adhere to guidelines that emphasize clarity, proper licensing, and thorough documentation. The platform also supports private packages for teams needing restricted access, catering to enterprise environments. As Flutter grows, pub.dev continues to evolve, adding features like automated security scans and dependency graphs, further solidifying its position as an indispensable resource for developers. The Confetti package exemplifies how niche utilities can significantly enhance user experience. Beyond games, it can be used in e-commerce apps to celebrate purchases, in social media platforms for milestone notifications, or in productivity apps to mark task completion. Its versatility stems from Flutter's cross-platform nature, ensuring consistent animations on iOS, Android, and the web. By incorporating such engaging elements, apps can foster emotional connections with users, increasing retention and satisfaction. The package's ongoing updates and community support ensure it remains compatible with the latest Flutter versions, future-proofing its utility. The Confetti package exemplifies how subtle animations can elevate user engagement by turning mundane interactions into memorable experiences. Designed to simulate festive particle effects, it is often used in gaming apps to celebrate victories or in fitness apps to reward milestones, creating a sense of accomplishment. The package leverages Flutter's animation APIs to generate bursts of confetti with customizable properties like color gradients, shapes, example circles, hearts, and movement patterns influenced by simulated physics. Developers can adjust parameters such as gravity, emission speed, and wind direction to create effects that align with their app's aesthetic, whether whimsical confetti showers in a children's app or sleek, minimalist bursts in a productivity tool. Performance optimization is a key consideration. The package efficiently manages rendering to avoid frame drops, even on lower-end devices. Its event-driven design allows animations to trigger on specific user actions, such as completing a purchase or achieving a high score, ensuring timely and contextually relevant feedback. By open sourcing the package, the Flutter community has enabled developers to fork and extend its functionality, leading to variations like staggered bursts or themed particles for holidays. Such adaptability makes the Confetti package a versatile tool for enhancing UX without compromising app performance. The Confetti package's impact on user psychology cannot be understated. Animations trigger emotional responses that static elements cannot. By celebrating user achievements with dynamic visuals, apps foster positive reinforcement, encouraging continued engagement. For instance, in educational apps, a confetti burst after completing a lesson plan can motivate learners to progress further. In e-commerce, celebrating a purchase with confetti creates a sense of excitement, potentially increasing customer loyalty. The package's configurability allows brands to align animations with their identity. A luxury app might use gold and silver particles, while a children's app could opt for bright, multicolored shapes. Beyond aesthetics, the timing and duration of confetti effects are crucial. Overusing animations can lead to sensory overload, so developers often tie them to significant milestones rather than trivial actions. Accessibility is another consideration. Developers might pair confetti with haptic feedback or sound effects for users